Hello friends, let's see one interesting topic. Okay, this is very important, especially in DRDO, ISRO, BARC, UPSC interviews. You can actually score more marks compared to others if you answer in this particular manner. Now I'll tell you how transients can be used for temperature measurement. Okay, small theory, small concept for measuring temperature. This actually I have come across in my research work. I was doing some research in automation. Okay, so I came across this particular thing, so I solved the problem like this, and it really works. In the second part of this video, I'll show you using Arduino. All of you might be knowing Arduino, so I'll show you how these transients can be used to measure the temperature in a room. Suppose, for example, let's take a simple circuit. Let's take a simple RNC circuit. Let's take a simple RNC circuit. Suppose, for example, for my convenience, let's say this is 10 kilo ohm and this is nothing but 10 microfarad. Okay, I'm taking a simple first order system, RC circuit. Suppose assume that if I apply an input, okay, if I apply an input V in, so what exactly happens? Tell me. So all of us know that when we apply, let's say 5 volts, when you apply 5 volts, okay, so the capacitor output voltage, if you start measuring at this point, okay, the capacitor output voltage rises like this exponentially as 5 into 1 minus e power minus t by RC. Let's see once again. What I'm teaching, I'm basically teaching some interesting application of network theory. So suppose somebody will tell you in interview, hey, network theory bahut pada, you have learned network theory so much, your favorite subject is network theory. How will you use network theory in real time? I am telling a real time application in my research where I have used this. ठीक है, मैंने इस्तेमाल किया. In the part 2 of this video, I'll clearly show you how I have developed the system using simple Arduino microcontrollers. ठीक है, so it's basically application of the network theory. ठीक है, it's a simple concept, not at all difficult, बिल्कुल tough नहीं है. It's very simple and very easy. Now suppose for example, now let me teach you. Suppose for example you have a simple RC network. Okay, you have a simple RC network, please. ठीक है, you apply 5 volts. Say for example you are applying at t0. You are applying at time t0. So what exactly happens? The output basically raises exponentially. ठीक है, as 1 minus e power minus t by RC. So this is what happens. Suppose for example let's mark a point. Let's say you are marking a point of 2.5. I'm marking a point of 2.5 volts. Now you tell, and let's say on the time scale it is reaching at a time t1. You are marking a point of 2.5, which is the midpoint value, and it is reaching at a time t1. So how to find the t1 value? Bataiye t1. You will understand in 2 minutes. If you're not understanding, I'll make you understand. It's very simple. Bilkul tough nahi hai. Not at all difficult. Very simple. I'm trying to teach you an interesting application of network theory. Okay? How the transients concept can be used for measurement of the temperature in a room, okay, or any furnace or any system. Okay? So now what I have done is I have taken a simple RC circuit. For my convenience, I have taken 10 kilo ohm and 10 microfarad. You can take any value. Okay? I applied 5 volts as input at t0. So I applied 5 volts as input at t0. So the output goes exponentially, and I'm marking a point of 2.5. Okay? So what I'll now do is, so at a time t1 it touches 2.5. The value will touch 2.5. Let's find the t1 value. कैसे करेंगे बताइए? So the vout is equal to 5 into 1 minus e power minus t by RC. This is the equation of the curve. And vout at a time t1, at a t equal to t1, vout is equal to 2.5. ठीक है, simply substitute कीजिए. So 2.5 is equal to 5 into 1 minus e power minus t1 by RC. Okay, simple. If I 2.5 by 5 is nothing but 0.5. Okay, so 0.5 is equal to 1 minus e power minus t1 by RC. Okay, right. So simply let's calculate the value of t1. So 1 minus 0.5 is 0.5. So simply t1 is equal to, simply you will get natural logarithm of 2 ln 2 into RC. So t1 is equal to 0.693 RC, and that's 0.693 RC. This much everybody knows. Okay. So ठीक है, ये you please remember this value, please. Understood? Now remember this value. T1 is equal to 0.693 RC. ठीक है, all of us know this. Okay. So now suppose for example I am teaching basically how to use network theory concept. Okay, how to get more marks in interview. Okay, very important from interview perspective in DRDO BARC. If they will ask you this question, how are you going to use your network? Many times they tell you what's the favorite. They ask you what's the favorite subject. ठीक है, you'll say my favorite subject is network theory. They'll ask, tell me one application, कैसे इस्तेमाल करोगे real time. So real time application is this. ठीक है, so how can we use a simple transient analysis? First I have taken a simple RC circuit. For this RC circuit, what I have done is I started measuring the 2.5 midpoint. So this time, okay, we got it. ठीक है, right, हो गया. Just keep it aside, right? Now suppose for example, now what I want to do, I want to measure the temperature, right? So now I'll take the same RC circuit, I'll take the same ditto RC circuit, 10 kilo ohm, okay, 10 kilo ohm, and this is nothing but let's say 10 microfarad. In this, and in series I will connect a temperature sensor, okay, I'll connect a simple temperature sensor, okay. So this is called RTD, the component number is called PT100. आप गूगल कर सकते हैं, PT100 is a temperature sensor whose resistance increases with temperature. PT100 का resistance जो है, okay, it's a component number, it's RTD, okay, it's a simple resistance varies with temperature, ठीक है. So the resistance increases with temperature, increases with increase in temperature, okay, increase in temperature. The component is called PT100, आप गूगल कर सकते हैं, you can just google it, ठीक है. It is designed in such a way, this resistor is designed in such a way, ठीक है, that at 0 degree centigrade इसका the value will be 100 ohm, okay, 0 degree centigrade में 100 ohm, okay, and around 200 degree centigrade it is around 180 ohms, okay. So this PT100 temperature sensor has a range from minus 200 degree centigrade to 850 degree centigrade. So it is a wonderful temperature sensor. It can be used in all the industrial equipments. तो मैंने क्या किया? Now let's see the magic. Now see the magic. What I will do? How to measure the temperature? How to measure the temperature using simple transient theory बताता हूँ, देखिए. So what I have done? I have taken a PT100 temperature sensor. I don't know the resistance. इसका मैं I don't know the resistance of this particular component. I don't know the resistance because the resistance depends on temperature. So I don't know the exact resistance. So now this I am connecting in series with a 10 kilo ohm resistance. Okay, and this is nothing but a 10 microfarad capacitor. So now let us apply. Understood? Now let's apply same story. Now let's apply a 5 volts input here. Let's apply 5 volts input at a time t0. So बताइए भाई क्या होगा? What is going to happen, please? Let's calculate the Vout now. Now Vout, what is going to happen? See what is going to happen here. If you just observe here, the series resistance is increasing. Previously कितना था बताइए? Previously it was only 10 kilo ohm. Previously only 10 kilo ohm was the resistance. But now this PT100 resistance is PT100 resistance. Okay, the temperature sensitive resistance is connected in series. So overall resistance increased, and overall resistance increased. The time constant will increase. Now when I give 5 volts, what is going to happen? It is again going to raise like this, exponentially raise hoga. Okay, now let us measure a point of 2.5. Let's measure a point of 2.5. Okay, so let's say 2.5 is reaching at T2. Let's say 2.5 is reaching at T2, please. Understood? 2.5 is reaching at T2, please. Okay, so T2 is the time where it is reaching 2.5 volts. Understood? 2.5 volts. So now simply same formula agar calculate करेंगे, how will you do it, please? So T2 is equal to, understood, T2 is equal to same story, okay, 0.693 into RC. So let's call this new R as R1, okay, into C, and as R1 into C. So now we are having equation, this is equation 2, okay, and this is nothing but equation 1. Understood? Equation 1. So now interesting point देखिए, very simple, ठीक है. So what is going to happen, please? I am teaching an interesting points, especially from the interview perspective, application of network theory, ठीक है, simple transient analysis for temperature measurement, ठीक है. So now how can you do it? So first step, I have taken 10 kilo ohm resistance, okay, and I have taken 10 microfarad capacitance, okay, I gave 5 volts input, okay. Now here, okay, we know that theoretically it goes like this, okay. I'll teach you with how I have done with microcontrollers. मैंने कैसे microcontroller से किया, I'll just explain that, ठीक है. But this is a concept. First of all, I gave 5 volts input to this circuit. Now what I have done, I have connected PT100 temperature sensor, okay, in series with 10 kilo ohm. So now let's say this time is T2. Now the resistance is increased, so RC time constant increases. Okay, the RC time constant increases now because you are connecting something in series. R value is increasing, RC time constant increases. So now let's call it as T2. Okay, so now obviously time constant increase, so you are getting equation 2. So now friends, let's see, this T1 is equal to 0.693, okay, R into C, and our R1 is equal to R plus delta, okay. This is nothing but 10 kilo ohm. Understood? This is nothing but 10 kilo ohm. This is nothing but the resistance of the PT100, which is depending on temperature. Okay, so it's depending on temperature, please. Understood? Depending on temperature. Simple. Okay, so originally it was 10 kilo ohm. This is equation 1. Originally it was 10 kilo ohm. Now you are connecting PT100 temperature sensor in series, so more resistance is there. Okay, so now what is going to happen? The R1 is nothing but 10 kilo ohm plus, okay, resistance of PT100, which is nothing but which is nothing but what do you say, which is nothing but 10 kilo ohm plus temperature dependent resistance. ठीक है, very very simple. So now अब कैसे करेंगे भाई? ठीक है, simple, understood, simple, very very simple. So now T2 minus T1 please, understood. T2 minus T1 क्या होगा? 0.693 into C common. Okay, you're having R1 minus R please, understood. R1 minus R. Okay, so T2 minus T1 is equal to, understood, T2 minus T1 is equal to 0.693 into C, okay, which is nothing but simply into delta R. Okay, R1 minus R is nothing but simply delta R, please, understood. Any temperature of the, okay, this is nothing but the resistance of the PT100, okay, temperature sensor. So simply we can simply calculate delta R is equal to, understood, delta R is equal to T2 minus T1 divided by 0.693 into C, understood, 0.693 into C. ठीक है, so directly you are getting the resistance of the temperature sensor. Now there are tables available please. PT100 का table available है, okay, PT100 table and graphs are available, okay, in internet graphs and table is available please. Okay, so 0 degree centigrade it is nothing but 100 ohm, okay, 100 ohm for, and for 185 degree centigrade, for 185 degree centigrade it's 163 ohm approximately, okay, approximately बता रहा हूँ, ठीक है, and for 200 degree centigrade it is around 175 ohm. Okay, so like this graph is available please, understood. Graphs are available for PT100. So directly see, if you know the resistance, you can get the temperature, okay. This we can create a small table, and keep it, ठीक है. Table available है, table को देख के बता सकते हैं, once you know the resistance, this is the resistance of PT100. Okay, now resistance of PT100 is known. From the resistance values you can easily get the temperature, understood. Easily you can get the temperature value from the table देख के बता सकते हैं. So like this easily you can use, understood. I'll also tell you how I have done using microcontroller. In the next video, part 2 video, I'll clearly show you program also of the Arduino. ठीक है, सिंपल आर्डिनो से कैसे इंप्लीमेंट किया. सो नाउ वी आर डिस्कसिंग एन इंपॉर्टेंट इंटरव्यू क्वेश्चन, ओके, फॉर बार्क, इसरो, DRDO, UPSC, एप्लीकेशन ऑफ नेटवर्क थ्योरी, ट्रांजिएंट्स को कैसे इस्तेमाल कर सकते हैं फॉर टेम्परेचर. ओके, सबसे पहले मैंने क्या किया, दिस एक्चुअली आई अप्लाइड इन माई रिसर्च वर्क. ठीक है, अप्लाइड इन माई रिसर्च वर्क. ओके, आई वाज ट्राइंग टू मेजर टेम्परेचर. आई थॉट ऑफ दिस मॉडल एंड इट्स रियली वर्किंग, इट्स रियली गुड, सिंपल इंटरेस्टिंग थिंग. So now you are having R and C, okay, so now you apply 5 volts input. I'm taking the midpoint. You can take any value, you can take 3.5 also, you can take 4 also. I have taken 2.5 as midpoint. ठीक है, so because only 0.693 will come, that's why I have taken, other than that nothing. So now सबसे पहले क्या किया देखिए, I have taken RC circuit, I applied 5 volts input, I calculated the, okay, T1, okay, where it reaches midpoint. Now I am connecting the temperature sensor, understood. Temperature sensor, its resistance increases with temperature. PT100 is the number, आप गूगल कर सकते, you can just google it. ठीक है, तो the temperature increases with increase in temperature. इसका range है -200 degrees roughly to 850 approx, okay, approximate इतना high temperature range के लिए काम करता है. Okay, so now I apply the same 5 volts. When I apply the same 5 volts, now resistance value is increasing, so obviously RC time constant increases. So now it is going to reach 2.5 at a time T2. I found out the time T1, I found out the time T2. So easily we can find the delta R is equal to T2 minus T1 by 0.693 into C. C value कितना है, 10 microfarad, understand, 10 microfarad. Now once you have the delta R, you can easily find from the table, you can find the temperature, understood. Temperature, exact temperatures, graphs available है, easily निकाल सकते हैं. How can we do realistically? ये तो theoretical हो गया. Now realistically how we can do? Simple, okay. Let's take a simple 10. I'll just show you how we can do it simply. Okay, simply now what you do is, this is, let's say, 10 kilo ohm resistance, this is 10 microfarad capacitance. Let's take a simple Arduino, okay, let's say Arduino Nano, okay, Arduino Nano, let's take a simple Arduino Nano, simple microcontroller circuit. It has got a digital pins, okay. Arduino will have digital pins and analog pins. Okay, so analog means ADC, please, understood. It's an analog input will be there, okay, digital pins will be there, digital input output pins will be there. Okay, Arduino microcontroller system, okay, it has got inbuilt ADC, it has got inbuilt ADC, 10-bit ADC, it has got inbuilt analog to digital converter, inbuilt ADC. ठीक है, so now मैंने क्या किया, simple, understand. मैंने what I have done is, let me just change the color. Okay, what I have done is the digital, okay, I'm connecting here, understood. Output pin I'm connecting as output pin, digital output pin I'm connecting here. ठीक है, this is the output pin. Okay, microcontroller का output यहाँ पे connect किया, and this analog input I have connected the capacitor value I have connected here. Okay, of course this is a common ground pin, understood. Common ground is there, I connected ground. Okay, this is a simple circuit I have connected. So मैंने क्या किया, सबसे पहले I have used a digital pin of Arduino. ठीक है, I have used a digital pin of Arduino as output, right, and I have used this capacitor voltage I am measuring as input to the Arduino. ठीक है, simple, understood, simple. So now what I'll just do, I'll simply say, okay, just to write the program, I will simply say digital write. I'll simply say digital write. Okay, so let's say this is pin 7 of Arduino. Let's say pin 7 of Arduino, 7 comma high. So when I simply say 7 comma high, what is going to happen? 5 volts will get applied here. Okay, when I say 7 comma high, simple. This is a simple connection to Arduino. बिल्कुल tough नहीं है, बहुत आसान है. I am taking a simple Arduino Nano microcontroller with a 10-bit inbuilt ADC. ठीक है. So now I am taking the digital output. Understand? I am taking the output pin of Arduino. Okay, digital pin of Arduino, using this as output, connecting here. Okay, common ground should be there. वरना काम नहीं करेगा. It does not work otherwise. So directly what I am doing, ठीक है, the capacitor voltage I am reading, okay, using the analog pin, यानी using the analog to digital converter directly. So simply what I'll do, first I'll make the, excuse me, I'm sorry. Okay, first I'll make the digital write, digital write, यानी okay, I'm outputting 5 volts. Okay, basically मैंने क्या किया, I'm outputting 5 volts, please, outputting 5 volts. This is basically, okay, you're outputting 5 volts. ठीक है. So now what I'll do is, understood, once I output the 5 volts, immediately what I'll do, I'll start the timer. Okay, I can start the timer, or instead there is a function called, okay, micros. I'll just say time equal to micros. Okay, it is basically calculates the time in microseconds. Okay, you can start the timer here, or you can, instead of timer, directly have used a function called micros, which actually, okay, is which actually tells us what is the exact microsecond at that instant. 5 volts input diya, I gave the 5 volts input. This is a pin number, please. Okay, so I gave the input, and I told simply time is micro, so I'm calculating the microseconds. Now what I will try to do, I will try to now measure the value. Understood? Now I will try to do analog read. Okay, I'll now try to do analog read. Let's say this is a pin number, let's say pin number A7. Okay, so I'll simply say analog read A7. Okay, so now I'll try to read the analog value. Understood? So now we are trying to read the capacitor value. Okay, so now we'll try to read the capacitor value. Understood? Capacitor value, simple. So basically you are making it high. Okay, and now you are reading the capacitor value. Understood? You are reading the capacitor value, reading capacitor voltage. Simply you are reading the capacitor voltage. Okay, so you're reading the capacitor voltage. Now you're reading the capacitor value. So now what you need to do, we need to check it when the capacitor will touch midpoint. Simple. Okay, so you are giving 5 volts, right? Okay, you are giving 5 volts as input. Okay, so when will the capacitor reach midpoint, we should see. Okay, 5 volts basically means 1023. Okay, in ADC 5 volts means it's a 10-bit ADC. Maximum value is 1023, please. Understood? 1023. So midpoint is 511 approximately. So what I will now do is, understood, I will check where my mid values range. It reaches the mid value. So I'll just check when the temp is, as long as temp is less than 511. Okay, I will keep running the loop. Understood? I'll keep running the loop. ठीक है, I'll simply say analog read. Understood? Analog read A7. समझ में आ जाएगा, 1 second बता देता हूँ. ठीक है, what I'm trying to do is, basically I'm trying to give 5 volts here. Once I give 5 volts, I'm marking the time instant. Okay, 5 volts कब दिया? When did I give 5 volts? I'm marking that time. Second thing, now I'm reading the capacitance value. I'm now reading, capacitance is increasing like this. Okay, I'm reading the capacitance value. ठीक है, till what point I should read? I should read till the midpoint. Why you are taking 511? Because the max value 5 volts is nothing but 1023 in terms of ADC. 5 volts is nothing but 1023 in terms of ADC. So midpoint is basically 511, approximately 511, 512. So I'm taking 511. So what I'm trying to do, the capacitor's value is raising. I am trying to check where the 511 is occurring. Understood? Okay, I am running the loop until my capacitance value, temp is capacitance value. Okay, it's a capacitance value is less than the midpoint. Okay, so that means in this region I am trying to calculate. In this region my while loop is running. Understood? My while loop is running. Okay, in that region my while loop is running, please. Understood? While loop is running. So what exactly happened? I will say, once I cross this region, while loop will break. I'll now take the time here. Understood? Again I'll now take new time. Okay, I'll now take the new time is equal to micros. Understood? Micros, it's an inbuilt function. Khatam. So the new time minus time. Understood? New time. Okay, new time minus time is nothing but this duration. Understood? This duration. That's it. I got the duration. Okay, I got the duration. Midpoint ka duration mil gaya. That's it. So similarly, understood? Similarly, very, very simple. You see, what I'm doing is I'm taking the simple RC circuit. Okay, it's a practical implementation. RC circuit. Okay, so now for this RC circuit, what I'm trying to do, I'm simply connected a microcontroller. Now I'm making the pin as high. उसके बाद I'm measuring the capacitance value by doing the ADC reading. Okay, that's what I'm doing. So now, so simply what I'm doing, I'm just reading the capacitance value. I'm just reading the capacitance value. Once the capacitor touches midpoint, why midpoint? 511. 511 because 5 volts is 1023, midpoint is 511. Understood? 511. I will calculate the time at that instant, time at this instant. The difference is nothing but this duration. Understood? Duration mil gaya, T1 mil gaya. Same story. Understood? Same story. Repeat. Now you take PT100. You take PT100. Okay, and you keep the remaining part of the circuit 10 kilo ohm, understood? 10 kilo ohm. Okay, capacitance 10 microfarad, everything same, understood? Everything same. You apply D7, understood? D7, you apply A7 here, understood? A7 digital, everything same. You will get the T2 value. You will get the T2 value. Concept is the same. Okay, now you will get the T2 value, and you have the formula here, understood? You have the formula T2 minus T1 is equal to 0.693 RC. T2 delta R equal to T2 minus T1 by 0.693 RC. Wonderful question. Wonderful concept, simple concept, बिल्कुल tough नहीं है, practically applicable, and I have tried. Okay, I have tried this. Understood? I have tried this. It works well. Okay, I'll show you the program in the next video. Understood? Next video I clearly show you how this concept I've used. It's very simple. 5 volts diya, I just gave 5 volts here, and I started measuring the capacitance value. When it touches the midpoint. It's like a counter. I'm using Arduino for counting basically. This I'm using Arduino for basically counting, please. Understood? Counting के लिए इस्तेमाल कर रहा हूँ. Okay, I hope all of you enjoyed this concept. Okay, thanks.